Everybody, and thank you for attending this session. This is AMD and Accelerating Edge Solutions with Ryzen Embedded. I'm your host, David Rosado, and for the next 10 to 12 minutes, I'll be talking to you about edge trends, challenges, and solutions from AMD and our partners from Advantech on edge computing and edge platforms. Like I said, I'm your host, David Rosado. A little bit of introduction about myself. I've been in the semiconductor business for about 30 years in different semiconductor companies, anything from engineering to marketing to business development. The last 6 years I've spent it with AMD Embedded Solutions, obviously for legacy equipment, industrial, medical, and edge computing solutions. And I live in Austin, Texas, in the USA. So again, let me start with why do we need the edge? And this should be probably redundant for some of you guys, right? You probably do know what you need the edge, but let me tell you from my perspective, it's all about control, cost, and security. Control in the form of owning your data and knowing where your data is. It's not in the cloud. It's not being snooped in the cloud. Only subsets of what you're allowing people to see are in the cloud. Also about cost. If you're talking about networking or edge computing that's placed in remote sites, let's say it's placed on a business street somewhere, or in the middle of nowhere in the windmill farm, collecting data about power generation. You want these devices to communicate to the cloud, but only when there is communication to the cloud to be had. In other words, you make decisions locally, you make computing locally, and then you can send that data to the cloud and have only short conversations with the cloud, saving you money. It's finally about security, and again, if you're in the banking or medical segment, you want to be able to tell your customers that that data is secured. You can use features in the SoC, in the computer, in the CPU device of these edge solutions to develop secure solutions, encrypted solutions that will be hard to hack. So it's about control, it's about cost, it's about security. That's why you need the edge. In terms of market trends, what I'm trying to do with this slide is enable you to see some of the use cases that are interesting in computing market trends in edge computing. For example, one of the things to understand is that AI or artificial intelligence will be a complementary service to cloud. In other words, you'll be able to make artificial intelligence solutions or decisions prior to sending information to the cloud. There will be increased bandwidth in the form of 5G that you'll be able to leverage and have therefore a device that is in remote placement but still able to do computation and uploading and downloading of data based on 5G technology. And in terms of the AMD or in terms of the edge inferencing workloads that you'll be able to facilitate, computer vision has the most success so far. You can envision computer imaging devices acting as edge servers all over the place, doing face recognition um, and, um, and motion detection, etc., to enable emergency service to be more accurate and to enable your business to operate at a more high level. So surveillance cameras in an edge system are going to be more of a compelling event for edge computing segments. In terms of computing and edge computing challenges, just you can envision that this edge computing devices are in remote sites where temperature is not controlled, where security may be needed because you're in a remote place sending data, where network connectivity will be also important. So therefore, let me show you why AMD in edge computing solves or mitigates some of these challenges. We offer devices for up to 10 years, allowing you to offer an edge computing device for up to 10 years to your customers. We also qualify some of our devices to extend the temperature, allowing for these edge computing nodes to be placed in remote sites where temperature may be of an issue. Scalability in the form of having 2 to 8 cores in the V1000, V2000 segments or V2000 platforms that can go from 2 to 8 cores and from about 6 watts to 54 watts, allowing you to have one board with multiple personalities depending on the CPU of choice. Network bandwidth, because we enable gigabit Ethernet on our devices, specifically on the V1000, and security, because we offer secure devices like secure processing and memory guard, encrypting the contents of the memory. In terms of Ryzen embedded V2000, why on the edge? Now we're going to give you a little bit more information about V2000. This is a device that was introduced as of November of 2020. It shows a 2x generational uplift in performance per watt. And this is basically a very revolutionary because 7 nanometer technology and Zen 2 core on the V2000 will allow you to show a device that at 10 watts can power 8 cores, allowing you to have fanless systems if you need, or fully high power performance devices at 54 watts with 8 cores. So a very compelling platform that can go as low as 10 and as high as 54, 6 and 8 core devices with extended scalability and support, in other words, up to 10 years of longevity and strong integration with powering up to 4K displays and integrated graphics with an enterprise class security features. And here's what the V2000 will look like. In other words, you have up to 8 cores, in other words, 6 and 8 core devices on a power envelope of as low as 10 watts, as high as 54 watts. 54 watts for higher performance, 10 watts for fanless and an optimal performance for low cost and power optimized devices. You can power up to 4K displays at 60 frames per second with encode and decode 10 bits, 20 lanes of PCI Gen Express. In the V1000 have 16, so now we're obviously offering an upgrade there with 20 lanes of PCI Express, 10 to 54 watts, 10-year plan availability. And again, this is the V2000. It's already in production. And our friends from Advantech will show you some very compelling platforms that they've been able to power using the V2000 SoC. In terms of performance, let me have 2 slides. The first slide will be a generational performance. This is comparing V2000 relative to V1000. And then a second slide that I'll also show that shows how V2000 fares against the competition. In terms of generational performance, you can see that in single threading, 25 to 30% improvement over V1000. But when it comes to multi-threading, which is the graphic here in the middle, we can show anything from 100 to 140% performance. This is because now you got 2 to 4 more cores to play with. So obviously in the same power envelope. And again, it's comparing a V1605, which is a 15 watt 4 core device, against a 6 core and an 8 core option for V2000. In terms of graphics, yes, we keep the drum roll, the drum beat by showing a 27 to 40% graphic improvement with 8 cores and the graphics in the V2000 relative to V1000. A little more interesting comparison is to show how the V2000 compares against other options. In the particular case, on the left side, there will be 15 watt TDP or total dissipation power comparisons of the V2718, in other words, 8 core devices compared against Whiskey Lake and Comet Lake. On the right side, there will be comparisons on the 54 watt side, maybe 35% nominal, for a V2000 relative to some Core i7 solutions. And as you can see, on the left side, we're almost on par on single threading, but on multi-threading, we show a definite advantage and also a compelling advantage when it comes to graphics. Also on the right side, we also see the same performance benchmarks, but again against a higher performance Core i7. And as you can see, very compelling value proposition in terms of benchmarks. Where does AMD play? So right now with V2000, we're completing the circle. We compete edge to edge, anything from the data center to the networking edge to the edge devices. On edge devices is where V2000 makes the most sense because of 8 cores and lower power dissipation. But in networking and edge, there's also use cases for Ryzen and V2000, Ryzen embedded V2000, and also for some Epic or data server kind of devices. And obviously on data server, we do have a compelling proposition also for data centers. Size that our friends from Advantech, have two already ready and enabled platforms leveraging the V2000, also for edge, industrial, and other segments. They do have a COMI Express SOM6872 and a Mini-ITX solution also featuring V2000 AIMB 229. This is the Mini-ITX, all with device management that allows remote management and control. In other words, being able to boot and to monitor remotely some of these solutions. Like I said, edge computing needs is also lives in remote sites. So remote management, obviously, very compelling value added from our friends from Advantech. In terms of the AIMB, this is the Mini-ITX product. As you can see, there is some benchmarks here on the lower left side, and it comes powered with Advantech Wise Device On, or their remote management for update and recovery. So this is a very compelling solution featuring the Ryzen V2000. Also, a CalMe solution featuring the Ryzen V2000 is ideal for signage, medical imaging, machine vision, and gaming. This concludes what I have to present to you. If you have any questions about this Advantech products, please contact your Advantech representative. If you have questions about AMD, also contact your Advantech or AMD representative about the compelling value of AMD in this type of solutions. We thank you very much for your attendance. Again, this is David Rosado. Thank you again for your attention, and please keep looking for introductions from Advantech and AMD on these segments and others. Thanks again.